Your grandpa's 50-year-old outboard fires up on the second pull. Meanwhile, your neighbor's 3-year-old motor sits at the dealer getting a $2,000 computer diagnostic. Something changed in how outboards get built, and it wasn't an improvement. These vintage pre-1990 motors weren't designed to last forever. They became indestructible accidentally through over-engineering and tolerances that welcomed wear instead of fighting it. Today we're looking at 15 vintage outboards still running strong after generations of use, engines that outlived their boats, their owners, and sometimes their entire manufacturers. Before we go ahead, subscribe to Engine Bay for more boat engine content. Now let's see what made them bulletproof. Start with the Yamaha that changed everything for American manufacturers, the 1978 Yamaha 15 horsepower. While Mercury and Johnson built sturdy workhorses, Yamaha built precision instruments. These motors featured advanced exhaust tuning for reduced noise and improved performance, plus thermostatically controlled cooling that maintained optimal operating temperature regardless of conditions. Yamaha's attention to detail showed in every single component. Stainless steel where competitors used plated steel, precision castings instead of rough forgings, fuel systems that maintained consistent mixture even as components wore over thousands of hours. The build quality meant these motors required less frequent maintenance while delivering consistent performance year after year after year. The CDI ignition system was fully waterproof and mounted in a sealed compartment, eliminating the water intrusion issues that plagued many competitors. Yamaha's propeller design included a unique blade shape that reduced cavitation and improved hole shot, making these motors particularly popular with water skiers despite their modest power rating. The precision manufacturing and quality materials created motors that simply refused to quit. Then there's the Mercury that marked a turning point, the 1972 Mercury 20 horsepower. This motor marked a genuine breakthrough with Mercury's Thunderbolt CD ignition, one of the first maintenance-free ignitions in the outboard industry. No more points to adjust or condensers to replace every season. The solid-state system provided consistent spark timing and virtually eliminated ignition-related failures. Commercial operators loved these motors specifically because they started reliably day after day without the constant fiddling earlier ignitions demanded. The potential issue with these motors was galvanic corrosion between dissimilar metals in the cooling system. Proper maintenance, including regular flushing and sacrificial anode replacement, prevented problems completely. Many of these motors are still in commercial service today, proving that proper care trumps design limitations. This model year also introduced Mercury's Quicksilver lower unit lubricant formulation, specifically designed for marine gears and still considered one of the best available decades later. The 20 used a single carburetor that provided smooth acceleration and reliable fuel delivery. Now the Johnson that simply won't stop. The 1968 Johnson 9.5. Johnson engineers built this motor with an oversized crankshaft that belonged in a much larger motor. The result was a 9.5 that could handle continuous operation and abuse that would damage less robust designs. The Johnson 9.5 had a unique carburetor design with multiple fuel circuits that provided optimal mixture across the entire RPM range. At full throttle, a secondary circuit opened to provide additional fuel, similar to a power valve in automotive carburetors. This gave excellent acceleration and top-end power while maintaining good fuel economy at cruise speeds. The motor featured Johnson's Gale-branded lower units on some models, which were actually manufactured by OMC, yet marketed under different names for various retailers. These motors came in both short and long shaft versions, with the long shaft being particularly sought after for sailboat auxiliaries due to their reliability and easy starting characteristics. The oversized internal components and simple design created a motor that just kept running regardless of how hard you pushed it. Here's the Mercury that powered the base boat revolution, the 1973 Mercury 50 horsepower. This four-cylinder inline powerhouse used reed valve induction for improved power delivery and throttle response. Mercury's exhaust tuning, developed through their racing program, extracted maximum power while maintaining reliability. The durability came from Mercury's robust lower unit design, essentially unchanged since the 1950s, yet proven through millions of hours of operation. The weak point was the water pump impeller, yet this was a maintenance item rather than a design flaw. Regular impeller replacement ensured cooling system reliability and prevented power head damage. The inline 4-cylinder configuration provided inherent balance, reducing vibration without the need for complex counterweights. Mercury offered this motor with their power trim system as an option, one of the first reliable hydraulic trim systems that actually held position without bleeding down over time. Bass tournament fishermen chose these motors specifically for their combination of power and dependability. When your livelihood depends on getting to fishing spots quickly, you need a motor that performs consistently. Don't overlook this legendary Mercury fishing motor. The 1965 Mercury Mark 110.9.8. Mercury built these with a revolutionary feature for the time, a rubber hub propeller system that would shear before damage occurred to the lower unit. While this is standard today, in 1965, it saved countless lower units from destruction. The Merc 110's ignition system used high-quality points and condensers that, when properly maintained, lasted significantly longer than competitor systems. The secret was regular maintenance. A few drops of oil on the cam follower and a periodic point adjustment kept these systems running reliably for decades. The robust magneto system generated strong spark even at low cranking speeds, making these motors easy starters even in cold weather. Mercury positioned this as their fishing motor, with throttle response tuned for trolling and a gear ratio optimized for larger props. The result was exceptional low-speed thrust that made it perfect for pushing heavy loads, which is why many are still found on commercial fishing boats today, serving reliably after 50-plus years. Then the Evinrude that hit the sweet spot, the 1974 Evinrude 15 horsepower. This motor featured Evinrude's refined loop charged 2-stroke design, which improved fuel efficiency and power delivery compared to earlier crossflow designs. The result was excellent fuel economy combined with strong performance. These motors featured an exceptionally durable cylinder bore treatment that resisted wear remarkably well when combined with proper oil mixture and regular maintenance. Compression readings on well-maintained examples often remain within factory specifications even after decades of use. The key was using quality 2-stroke oil and maintaining the correct fuel-to-oil ratio religiously. The 15 came with Evinrude's Simplex recoil starter, which used a unique cam design that made starting easier than competitors' direct engagement systems. Many owners report these motors starting on the first or second pull, even after sitting for months thanks to the efficient fuel pump design that maintained prime in the carburetor. The combination of efficiency, reliability, and easy maintenance made these motors favorites among weekend fishermen. Here's where Japanese precision met small outboards, the 1980 Honda BF 75 7.5 horsepower. This motor proved that 4-stroke technology could work in small outboards long before the industry accepted it. Based on Honda's proven industrial engine designs, the BF 75 was incredibly quiet and fuel efficient. Fishermen initially worried about the lack of traditional 2-stroke sound, yet the ability to troll all day on a gallon of gas converts quickly. Honda's use of overhead valves and precision manufacturing meant these motors maintained consistent power output throughout their entire service life. While parts were metric and initially hard to source in America, the exceptional reliability meant repairs were rarely needed anyway. These motors demonstrated that 4-stroke outboards could be practical, setting the stage for industry-wide changes decades later. The BF 75 featured a centrifugal clutch that engaged smoothly at around 2,000 RPM, eliminating the gear clash common in manual shift motors. The air-cooled powerhead with water-cooled exhaust meant these motors could run out of water for testing without damage, a feature mechanics particularly appreciated. Now the Johnson that represents the pinnacle. The 1976 Johnson 25 horsepower represents the pinnacle of Johnson's 2-stroke development before emissions regulations changed everything. This motor combined proven technology in a refined package that worked reliably season after season. The powerhead was robust, the lower unit overbuilt, the ignition system reliable. Johnson used high-quality seals and gaskets throughout, which is why these motors often retain good compression even when stored improperly for years. The manual recoil starter was so well designed that it rarely failed, using a shear pin system that protected the mechanism from damage when someone pulled too hard. The 25 featured Johnson's first successful application of exhaust tuning for noise reduction, using a rubber-mounted lower unit that decreased vibration transmission to the boat. This model year also saw improved corrosion resistance through better primer and paint formulations, which is why many still sport their original finish despite decades of saltwater use. The combination of power, reliability, and refined design made these motors incredibly popular. Here's the two-cylinder Johnson everyone trusted, the 1958 Johnson Seahorse 35. This motor earned its reputation as old reliable through years of trouble-free service in demanding conditions. The Seahorse 35 featured Johnson's improved neutral clutch system after earlier models had engagement issues that made docking an adventure sport. What made this 35-horse wonder last forever was its incredibly simple cooling system. While modern outboards have thermostats, pressure valves, and multiple sensors, the Seahorse used direct raw water cooling. Water went in through the lower unit, circulated through the block, and exited through the telltale. If it clogged, you cleared it with wire. The simplicity meant fewer failure points and easy field repairs anywhere. The two-cylinder alternate firing design created a distinctive sound that old-timers can identify from across the lake even today. Johnson used a pressurized fuel system with a two-line setup that prevented vapor lock even on the hottest days, solving a common problem with gravity-fed competitors. The robust construction and simple design created a motor that could be fixed with basic tools anywhere. Don't forget the tiny Evinrude with big motor durability. The 1962 Evinrude Light Twin 3 horsepower. This little two-cylinder motor weighed just 28 pounds, yet had exceptional build quality that rivaled motors 3 times its size. Evinrude used bronze bushings in the lower unit that were designed to last the life of the motor, and incredibly, they usually did. Many light twin 3s are still running with original lower unit components after 60 years of use. The Light Twin 3 could be optimized with simple carburetor adjustments and propeller selection to improve performance. The factory settings were conservative to ensure reliability across all conditions, yet knowledgeable owners could safely extract better performance through minor tuning. The integral fuel tank held just under a gallon, yet the remarkable fuel efficiency meant you could fish all day without refueling. The folding tiller handle and lightweight design made it perfect for car toppers and small tenders, explaining why so many have survived in excellent condition. Then there's the Mercury beauty that everyone collects. The 1956 Mercury Mark 25. This 20-horsepower beauty featured Mercury's Thunderbolt ignition system, which was essentially a magneto-based system that proved incredibly reliable over decades. What made it special was the robust aluminum alloy powerhead that Mercury cast with generous material thickness, creating an engine block that has survived decades of hard use. The Mark 25's two-cylinder design pumped out honest horsepower. When Mercury said 20 horses, they delivered every single one. These motors used a simple recoil start system and a basic carburetor that any mechanic could rebuild with standard tools. The lower unit featured bronze bushings and gears cut with tight tolerances that actually improved with initial wear, creating a perfect mesh pattern that would last for decades. The distinctive green color with chrome accents made these motors instantly recognizable at any boat ramp. Many collectors consider the Mark 25 the most beautiful outboard ever made, with its Art Deco styling reflecting the optimistic design language of the 1950s. Here's the small Yamaha that outperformed everything. The 1982 Yamaha 85 horsepower showcased Japanese precision manufacturing at its absolute finest. The three-cylinder design was inherently balanced, yet Yamaha's tight tolerances and careful assembly made these motors exceptionally smooth even at high RPM. The precision-cast powerhead and carefully matched components meant minimal vibration across the entire operating range. These motors featured Yamaha's oil injection system that provided precise lubrication based on throttle position and engine speed automatically. The CDI ignition system was bulletproof, and the lower unit used high-quality gears and bearings that lasted remarkably well under hard use. Many racing organizations had to specifically limit modifications on these motors specifically because they had significant untapped potential from the factory. The 85 introduced Yamaha's Prime Start system, a manual primer that eliminated the need for choking and made cold starts remarkably easy. The exhaust system used a tuned expansion chamber design that broadened the power band, providing strong acceleration from idle to wide-open throttle without the peaky delivery common in other performance two-strokes. Now the Mercury that borrowed racing technology. The 1985 Mercury 75 horsepower incorporated technology directly from Mercury's racing program. While this wasn't a true Black Max racing motor, it benefited from race-proven components, including forged connecting rods and high-performance reed valves. The aggressive ignition timing and porting provided strong acceleration and impressive top speed for a motor this size. Mercury used premium bearings and seals throughout these motors, contributing significantly to their longevity under hard use. The three-cylinder design with through-hub exhaust provided excellent performance while maintaining reasonable fuel consumption. These motors earned a reputation for being able to run hard all day without issues, making them incredibly popular with performance-oriented boaters. The 75 featured Mercury's ADI, adjustable driver input system on tiller models, allowing fine-tuning of throttle response for different applications. The switchbox ignition design proves so reliable that many are still functioning with original components decades later, requiring only periodic coil replacement as preventative maintenance. Here's the Johnson twin that commercial operators loved. The 1977 Johnson 55 horsepower featured Johnson's VRO, variable ratio oiling system, which automatically mixed oil with fuel at the correct ratio for operating conditions. While some operators disabled the system, preferring pre-mix, when properly maintained it provided excellent lubrication while reducing oil combustion and smoke. These motors used a robust two-cylinder powerhead with generous porting and strong internals. The aluminum alloy used for the block provided excellent heat dissipation, allowing sustained high-speed operation without overheating issues. Commercial operators appreciated the combination of power and reliability, making this a favorite for charter boats and water taxis that ran daily. The 55 introduced Johnson's Power Pack Ignition Amplifier, which boosted spark voltage for improved starting and better performance in humid conditions. The cross-flow scavenge design, while less efficient than later loop-charged motors, proved incredibly tolerant of carbon buildup and required less frequent decarbonization than competitors. This forgiveness made it perfect for operators who pushed maintenance intervals. And finally, the Evinrude that represents peak two-stroke development. The 1987 Evinrude 70 horsepower represents the culmination of traditional two-stroke development before emissions regulations changed everything forever. Evinrude pulled out all the stops using premium materials throughout, including needle bearings, forged crankshafts, and robust cooling systems with large passages resistant to blockage. The powerhead featured Evinrude's refined loop charging system with boost ports for improved low-end torque. The VRO system had been perfected by this time, providing reliable oil injection that operators actually trusted. These motors represented the sweet spot of power, reliability, and simplicity that made two strokes dominant for so long. The 70 came standard with power tilt and trim, using a reliable hydraulic system that rarely needed service beyond fluid changes. The distinctive ram exhaust housing improved mid-range power while reducing noise levels to meet increasingly strict regulations. Many consider this the best all-around motor ever produced, combining modern features with traditional reliability in a package that simply worked. So what makes these vintage motors actually last? Look at these 15 engines and clear patterns emerge. They were overbuilt during an era when manufacturers competed on quality rather than price. Engineers had the freedom to over-design components. Environmental regulations hadn't forced compromises yet. Simplicity meant anyone could maintain them. Unlike modern motors with complex electronics and emission systems, every component on these vintage outboards can be rebuilt with basic tools. They represent a philosophy of repair over replace that's vanished from modern manufacturing. The secret modification that doubles their lifespan. Replace fuel lines with ethanol-resistant ones sized larger than stock. Original lines were designed for pure gas, and modern ethanol fuel flows poorly through them while degrading the rubber faster. These motors last specifically because they were accidentally over-engineered. Loose tolerances welcomed wear instead of fighting it. Components were sized generously. Everything operated well below its stress limits constantly. Estate sales in lakeside communities hide thousands of vintage outboards sold for scrap prices. Your next reliable fishing partner might be hiding in someone's dusty garage right now, waiting for someone who recognizes what makes these motors special. What vintage outboard are you running? How many hours does it have? Drop your stories in the comments. Real-world experiences from actual boaters help preserve this mechanical heritage for everyone. Thanks for watching.